All right, so you are not gonna see a question like number one on the AP test. That is not a calculus level skill, looking at the actual function and deciding increasing or decreasing. It's more algebra 2 pre-calculus level, but I still want you to be able to do it. And so I feel very confident that you guys got these intervals. Make sure you have brackets instead of parentheses, just because we do include the endpoints on our intervals. So we're just basically looking for positives and negative slopes, or as you go from left to right, it's moving upward. All right, this is calculus level. So whenever you see a graph and it's asking you something like intervals of increasing and decreasing, it's probably the derivative graph they give you. So pay attention, because 2 is definitely the graph of the derivative. So what do you guys think about increasing intervals? When the derivative is positive, so that's going to be from B to D. And then again from F to H. And the reason is G prime is positive. Right, and then we're looking at derivative and we're deciding decreasing intervals. We're looking for negative, where the derivative is negative. And then the next one is the same thing. We have the derivative, and we're deciding the intervals of increasing, decreasing of the original function h. This one is a little tricky. This right here, where it actually touches the x-axis, that you feel like you might not want to include it, but we do include it. So when we're doing the intervals of increasing, we are going to start with A to B. And then we're going to go D all the way to H. And it's the same reason. And then decreasing, we're looking for where the derivative is negative. All right. And then your check for understanding. If you are looking at a function, how can you tell whether the value of that function is positive or negative? Yeah, so I said above the x-axis for positive, below the x-axis for negative. You can say above 0. As long as you understand that that's the y, you're fine. This is really for you to put in your own words. You don't have to use my exact words. All right, and then the next one, what condition on the derivative of a function would guarantee that the original function is increasing? And that's that the derivative is positive. And then guarantee decreasing, the derivative is negative on that interval. And then the next one, we have two graphs. One of them is the solid curve, one of them is the dash curve. One of these is going to be g, and one of them is going to be the derivative of g. All right, so look at those two. If you have the derivative, then that means everywhere on that graph is the slope of the original graph g. So which one do you think is the original, the solid or the dash? The solid is dash. I mean, the solid is the original. And we're going to say h is the derivative of g. Did you guys have a long night last night? I know some of you did. All right. Now, we're going to list as many reasons as we can for why h is the derivative of g. So what's one thing that made you make that decision?
The points of inflection on the solid graph are where the dashed graph crosses the x-axis.
Not the points of inflection, the relative maximum, relative extrema. That is one of the reasons. So we're going to say, which kind of what she said, h of x is 0. That's where it crosses the x-axis at 3 different points. So we're looking at the dash 0 at x equals c, x equals e, and x equals h. So then g of x, you can say has relative extrema there. I'm going to say has a horizontal tangent there. So that's where the derivative is 0. So the derivative graph is 0. All right, let's think about first derivative test. What happens when there's a relative minimum? How does the derivative change when there's a relative minimum? Negative to positive. So if I'm looking here at C, the derivative is changing from negative to positive. And then if I look at G, the solid curve, then there's a relative minimum there. That verifies it or justifies it. Right? Can you think of another reason that's similar to that?
G
I think you said it vice versa. So we have here where h is 0 and then g has a maximum. And at that 0, the derivative changes from positive to negative. Oh, that actually is a coincidence. That might be a point to throw you off. All right, so h of x changes from positive to negative. At x equals h. And then g has a relative maximum there.
So why did we say that on the first one, h of x is 0 and x equals e?
At x equals h?
X equals
It is. Oh, it isn't. Just kidding. It should have been f. Thank you. Okay, and then can we say something about intervals of increasing and decreasing for g? What do you notice about when g is increasing and the derivative graph? So here g is increasing. What's happening on the derivative graph? Is positive, is graphed above the x-axis. So let's make some statements about that. So h of x is positive. All right, let's see where. H of x is positive from, looks like C to H. Yep. And those same intervals, g of x is increasing. All right, there's one more statement. Let's see if you guys can write it on your own. So connecting the relationships between the derivative and the original function is super, super important in calculus. After sometime next week, we'll also see relationships between the second derivative and the original graph and the second derivative and the first derivative. It's really, really important.
Did you write one of your things about how h of x is 0 and x equals f and g is constant?
Yeah, well, we kind of did that on this first one. So we have that, and then the horizontal tangent is kind of a little baby constant section. So if your light blue one, if you left out that and you wrote that there were relative extrema at C and H, then you can write one more statement about that F. All right, any other questions? Okay, we're going to do part 2 together, and then the rest of the packet is going to be for you to do for your assignment. And they kind of like may give you a whole lot of space to do pretty much what we did yesterday. All right, so we have this function, and we are going to find where f is increasing and decreasing. So what do we need to find? The derivative. Then we need to find the critical numbers, or sometimes it's called critical numbers, critical values, or critical points. They all mean the same thing. They are where the derivative is 0 or undefined. All right, so we have 2 of these guys that we're going to put on the number line. And we're just doing increasing and decreasing, so we need to know when the derivative, or what the derivative is doing in between these. Because these critical numbers are the only values where it could change from increasing to decreasing or decreasing to increasing. So we're going to plug in numbers from each region into the derivative. And we don't have to get exact values, we just need to know positive or negative. And then if you want to draw your little arrows, you can. And when it says to explain your answer, you are going to have to give some explanation using the first derivative. And so you could say something like f of x is increasing on because f prime of x is positive on those intervals. And then something similar for decreasing. Oh, I messed up a little bit. Don't forget that if the function is defined at those values, those critical numbers, we do include them in our intervals. All right, what questions do you guys have? All right, so we can skip this check for understanding, but when you guys go to do your first one, number 1 here, where you have the first derivative, and you're finding the critical numbers, They're having you do, there's a section for each critical number to decide if it's a relative maximum min. So you don't have to use all those boxes if you don't want to. So that's up to you. And then the last one is just a regular question. It's a little more challenging. What's going to make it more challenging to find the derivative? Number 2. You have to do the quotient rule. It's doable. You can do it. It's just gonna it's just gonna be a little more challenging than just a regular old polynomial. You guys are good at the quotient rule.